Let's find the velocity from a position time graph. In this example, I have two different line segments over the course of the motion with two very different slopes. Um, let's start with the tricky, easy one. uh, it's easy once you get the trick. What is the average velocity? What is the average velocity from over the whole motion? So that would be from t equals 0 to... The definition for average velocity is that it's equal to the change in position over the change in time. In this case, what is the change in position from 10 to 0? It's actually 0. So you get 0 minus 0 from the top, and it doesn't really matter what the bottom is. So 0. So the average velocity is 0. But we can also ask, what are the two velocities in the two different segments? So let's do that. So what are the two different velocities in the two different segments? So what is the velocity from 0 to 4 seconds? And then I'll also do what is the velocity from 4 to 10 seconds. So from 0 to 4 seconds, it goes all the way up to the top of the motion. I just can't read the axis on the screen. It's a 12. So the average is equal to delta x over delta t. The top of the motion is 12 meters, as we just said, 12 meters, and then the bottom is 0. So 12 minus 0 over that 12 happens at 4 seconds. 4 seconds also minus 0. So we get 12 over 4 meters per second, and that is 3 meters per second. So the first segment has a slope of 3 meters per second. Again, for that segment, so if I wanted the average velocity or the instantaneous velocity, sorry, that's running off the side of the screen, but those are actually the same. The average velocity is equal to the instantaneous velocity for any straight line segment. So for just from 0 to 4 seconds. We know that it's not the whole motion because we know the whole motion had an average of 0 because the displacement was 0. Then let's do what is the average velocity or the velocity, both are the same, from 4 to 10 seconds. Same idea, delta x over delta t. This time, the final position is the end one, right? We're starting here and going there from 4 to 10 seconds. So we have the 0 meters minus the 12 meters and 10 seconds minus 4 seconds. So we get 12 meters over 4 seconds. I'm sorry, 10 minus 4 is 6. 12 meters over 6 seconds gives, oh, and it's negative 12 meters, right? 0 minus 12 is negative 12 meters. So negative 12 meters over 6 is negative 2 meters per second. So the negative sign indicates that the slope is going down and that the final position 0 is less than the 12 for that part.